In recent times, wind power technology has been increasing in its implementation, just as you have for solar. But the number of professionals going into wind power is far less than the market actually demands. This video series is actually inspired by an analysis which was done by an organization to show the number of people that are actually required to be engaged in this industry in order to make it more productive. Hi there and welcome to Catchment of Resources. This is QBlade Wind Turbine Design Modeler, Wind Power Course Part 1. In this video, we are going to look at the purpose of this video series, which we will detail one after the other. We will look at wind power online courses, benefits of QBlade, how NREL's OpenFast is being validated to QBlade. We will look at downloading QBlade, downloading model and test files. We will then focus on user documentation, and lastly, we will go over the graphical user interface to see how it actually works. In the next video in this series, we will then go in depth as to exploring one of the models, and subsequently we will look at how to generate a model from the data up to analysis and simulation of the wind turbine system. Recently, there was a post by DTU where they discussed the labor shortage and the state of the market for wind power. And while reading this post, it actually inspired me to do other videos on wind turbine systems. You know, there are several wind turbine modeling softwares that are available for use, but most of these applications are paid for because the wind power industry is actually one that requires a lot of research, of which a lot of research has been done. So it's quite an expensive sector because a lot has been invested into it. So a lot of the softwares to carry out wind turbine system design and components is actually not free. All of these applications are paid for. But luckily, these organizations like the NREL and DTU have made available applications that can be used for free. So it can actually be used for academic purposes. If students are able to begin using some of these softwares, it will now help them when they are possibly recruited by organizations that actually implement wind turbine and wind power technologies, because you're already used to the user interface, the framework of these applications. So it's sort of like an entrance training into this course. So sometimes we may say we need, most of the young people may need funding or grants in order to be able to study wind power. But I'll say just as you have for IT and other sectors, there are several freely available courses and softwares that people can begin to use to train themselves, like an introductory course into the wind power sector. So there are several courses online on several platforms, but if you check on one of the platforms, you will see this course. You will see wind resources for renewable energies. I've done this course before and I've actually gotten a certificate on it, as well as wind energy. One is from Eco University Polytechnic, and the other one is from DTU, which is Denmark Technical University. I actually got certifications in this before I proceeded to get a master's in sustainable energy engineering. So currently I possess a master's in sustainable energy engineering, and I've worked briefly on solar. Apart from the wind power courses on this platform, I'll just mention there are other renewable system courses on this platform. So you can actually go through all the different renewable energy options on free online courses. If you go to this platform, you will see many other ones, but the focus here today is on wind power technology. So aside the courses that you can actually do online, which are for free, there's two other programming applications that people need to actually understand and know how to use because it's useful for wind power data analysis. Is Python and MATLAB. So it's not necessary to learn both of them. You can actually choose one. Actually, either you're choosing Python or you're picking MATLAB. So these applications can actually be chosen in order to carry out design for data analysis for wind power system. So there are previous videos I've done, which are a link above, which is on NREL's OpenFast wind turbine system program. That does not really have a well-defined user interface as QBlade does. but NREL's OpenFast is a forerunner in open source wind turbine design systems or programs. I've decided to begin this video series on QBlade's Community Edition application because of the many benefits. One of them being QBlade has an interactive user interface that could be beneficial for people who like interacting with a visual screen rather than just working with code and programs and spreadsheets. But this one is a regular interface where you can have more interaction with the different commands, but this time you'll just be clicking and typing in values. Also, there are other models. There are larger wind turbine and more modern wind turbine models with more data that you can actually edit and input data to your own desire. With NREL's OpenFast, the initial versions that they released, you were limited on how much you can actually change some design data that was inbuilt into the program. But with QBlade, you have more flexibility in terms of what you can edit and what you will have you will not have access to. Also, there is a possibility of validating NREL's OpenFast design results. You can validate them with QBlade. So when you talk of validation, you are trying to follow different approaches, and the intention is that you want to see similar results, probably with some little tolerance. So you can validate NREL's OpenFast to manual calculations. You can validate QBlade to NREL. You can validate QBlade to manual calculations. So that's what validation is all about. So you just have a little tolerance or percentage error between the values you will get from the various approaches and methods you use. So it's a useful tool to use for validating this application. I've previously done videos on NREL's OpenFast, and within those videos I also discussed wind power or wind energy technology and some of the areas where you actually need Python programming, even to the generation of airfoil and the rest. But in this QBlade, we are going to look over it in other parts of this series. So basically, those are the reasons that have inspired me to begin this series on QBlade. So let's go into the main website of the producers of this application. So this is the website of QBlade, where you have the description of the application and what it does. So you can see the different models that have already been inbuilt. You see there are 1, 2, 3, 4, 5, 6, 7, 8, 9. But when you check the different models that have been done, there are about 12 models. So this is a basic description of the application and the fact that it was validated. They are just trying to prove to you that it has validated results. So this is a 3D animation that was done on this QBlade application. So there are different licenses for this application. So you have the free application, which is the academic one, which we are going to download and install. Then you have the enterprise version, which is the paid version. So if you've gone to QBlade.org, you then go to downloads. So on the downloads page, you are going to see various instructions and descriptions. So it gives you sort of like a disclaimer and other how you can use the application and give proper attribution and the rest to this for the producers of this developers of this application. So this is sort of like an academic public license, this community edition QBlade CE. So if you scroll down, first of all, you'll see QBlade CE download. So these are the executable for the software itself. So it depends on your the platform on your computer system. So you have Windows and you have Linux. So mine was Windows, so I downloaded this version. So it's to download it is not complicated. It's quite straightforward. Unlike when we were doing the videos for OpenFast, where we had to copy one file here, copy one file there, build it, and generate several files. Here it's quite straightforward because everything has been inbuilt in an application that has a user interface. So once you have downloaded any of this, you can then open the application and you'll see what's there. So prior to us opening that application, you can see here they have already produced model files. So in these model files, they have already described the diameter of the wind turbine, whether it's vertical axis wind turbine, horizontal axis wind turbines, or a propeller. All of these have been defined, the diameter, each of the individual elements, airfoils, their cross-section, their rotation, their in terms of the angle of attack and the rest. All of those things have already been established, even to the extent of let's say river, ocean data, wind data, and the rest. You can actually generate it, but there's some basic information that has been provided for you. You can use these model files to actually generate the actual values and give you some design results. So you see how so you see model files IEA 22 megawatts monopile. You see for open fast way it actually stops at 5 megawatts, but this is 2024 and the sizes of wind turbines blades have increased in diameter. So the power capacity of these wind turbines are rising. So you have 25 megawatts here, 15 megawatts for different models. Then you then have, so they also did a design according to NREL zone 5 megawatts OC4 semi-submersible offshore wind turbine system. So you can actually validate this with what you already have in OpenFast. So you also have another one here, an NREL 5 megawatts. So NREL has already developed its own airfoil combination and rotation and the structure of the airfoil, the wind turbine blade. So these wind turbine blades were developed by them. So different organizations and companies have their own wind turbine blade configuration. So this is according to NREL zone standards. So you have other ones here. So what is different here is primarily the 22 megawatt capacity and 15 megawatt capacity, which is higher than what NREL did several years ago. So you also have a VOT as well, Sandia 34 meters, then a propeller as well. So you have another one from DTU, another wind turbine configuration. So once if you pick all of these files and you download them one after the other, it's actually going to come out as a zip file. So you have to unzip it to get the actual QPR file, which is the QBlade file. So aside that, you also have some test files that you can also use to validate various information once you have access to it. Then for those who are tech savvy, that are used to programming and code, you may want to get a copy of this the source code for this community edition of QBlade and update it. Maybe you want it to generate a different report for you or other customization features or desires. You can actually take this code and update it accordingly. But you need to remember that you need to check the license of this community edition, because even if you are updating the code that have been provided to you, you don't have a right to distribute it either for financial or non-financial reasons. You don't have a right to distribute what you have updated, but you can actually look at the license definition for this academic public license to know the boundaries within which you can actually express yourself. So that's it on downloading. So once you've downloaded the executable and all of these model and test files, you can open up the QBlade interface. So before we go into looking at the user interface, let's quickly go to QBlade user documentation. The QBlade documentation is actually online. I've tried to get a PDF copy of it, but I'm finding it difficult. If you are someone who knows how to generate that, I will gladly appreciate it. But that of OpenFast, once you look somewhere below this tab where you have the link, various links, you can actually select doc as PDF file and download it directly. But here I'm unable to do that. Even when I copy this link and tried it in other websites, I was having some challenges. So if you are someone who can actually do that, I'll really appreciate it. Because if I have a PDF copy of this documentation, it will enable me to have easier access than if I have to come online all the time to gain access to this documentation. So basically, the QBlade documentation looks at various aspects. So it just gives you a general overview of the different theories behind the design framework of QBlade. So for wind turbine systems, you are talking of either land or at sea. You're talking about your design of values from the wind, design of aero, how the blade performs, structurally, the substructure, the support, and other things. So you see, there are different theories behind behind wind power. Basically, there are different theories. So all of these have been summarized as 4 basic theories. You have aerodynamics, hydrodynamics, structural dynamics, environmental conditions. So if you go over them one after the other, you'll see what it actually implies. So over time, as you are looking at this, you realize that there are 2 versions of QBlade. So you have the CE and the EE. So the CE is the community edition, which is the free one that we're able to download and we will look at very soon. While you have the EE, which is the enterprise edition, which is the paid version with a license that has more functionality and capabilities. So if you want to, you can go over the various aerodynamics, all the various theories. They are basically 4. So those courses online that I showed you earlier, the wind power courses that you can do for you and Eko Polytechnic, they'll discuss most of these theories. So they would have updated this course, and these courses can actually include more recent information. But aside those online courses, you can also get a wind power book and study the book, because, for example, in the wind power book, it talks about things like Prandtl tip loss factor. So there are corrections they have done. But most of the online courses, they'll just show you the basic way to estimate the various parameters for when you carry out blade elements momentum design for a wind turbine blade. But when you study the literature, books on wind power, you actually see correction factors that help you to get more accurate values. So for those who want to validate what has been done in QBlade, you can also compare all of these theories to what you have in wind power literature. So aside aerodynamics, you can then go to hydrodynamics. Look at, so Morrison equation is one of the popular equations or common equations with hydrodynamics, where you are talking of estimating the combination of tidal waves, currents, and waves in general. So you can actually do all of those calculations with Morrison equation. But here everything is automated. It's all combined together and automated. So you have structural dynamics. So whether it has to do with the blade, the support, the main and pull of the wind turbine system, the foundation, fixed end moments, and all those degree of freedoms. So it focuses on all those areas. Then lastly, you have environmental conditions. So you are talking of the wind, the waves, and the soil. So when you're talking of soil, definitely you may have to relate with so you can see soil structure interaction. So maybe if you have a pile foundation or a pad footing, but in any case, if you are embedding your structure into the ground, then there's going to be a structure column structure versus soil lateral interaction. So prior to when you have the bottom, that's the pile foundation or strip footing or pad footing, whichever you use, but it's most likely going to be a pile foundation with a pile cap. Anyway, the column is going to interact with the lateral head pressure. So these are things that are considered in QBlade as well. So going aside the theory, you also have the user guide, which is basically where we focus on today. And not fully, we'll just take a brief overview. So we'll just focus on one segment, which is the general GUI functionality. So that's the graphical user interface. So you can see showing the whole image. So but today we are going to explore the graphical user interface. Basically we'll look at okay, if we look at this image here, the interface has been segmented into 1, 2, 3, 4, 5, 6. But when you are doing your own design or accessing it, it may actually be less. So this is what it actually looks like. So sometimes you may say you want to view, you can see here, if you look at the third, either third or fourth row from the top, the third tab from the top, you can see 3D view, graph view, dual view. So the dual view will show you the graph view to the extreme right and the graphical view and the view of the simulation at the middle. But if you select just 3D view, you're only going to see the model view spread out. So you have general settings, so there are different things you can actually change. So these are things that you can actually study on your own to see how it works, but it's just for you to know that these are all here one after the other. So it's when it comes to the point of where you want to generate your own wind turbine configuration, then you now select each of them and use it one after the other. So in this video I just want us to see how the models that have been generated by QBlade actually works. That's why I want us to go straight to I just wanted us to look at how the QBlade how it looks like in the user documentation. So coming here, this is the first page you see once you open the application. So if we now go to load, so we have several projects. So the ones I've downloaded in the past. So if you have, let's pick the largest one. Let's say the monopile 22 megawatts wind turbine system. So we go for monopile. We open it. So I don't know, sometimes it actually generates, you see the wind turbine system from the get-go, but some other times you have to, you can see here airfoil design module. So on this second toolbar, you can see this. So if you zoom out, you can see all of the blades, all of the different cross sections of this wind turbine blade. So the elements cross sections. So even in the previous videos I've done, I've shown a website where you can get the standard, all the points for standard wind turbine or airfoils in general, whether it's for airplanes, it's for propellers, it's for wind turbines, those different configurations from NREL and other standard organizations that have generated this. But you see for QBlade has imported all of these standard airfoils. So if you want standard airfoils, you can actually come into QBlade and what they call it, load those kind of airfoils. But there are all other airfoils that are not within QBlade. Those you have to import. As time goes on, you actually see how that is done. So as you go from one tab to another, you will see that you need to generate some information. So this has already previously been modeled. So they are modeling mostly the geometric information and information. Then when you talk of when you now look at this is now having to do with airfoil information. So it can actually generate different different airfoil properties. Different aerodynamic properties. So to generate them for you once you select different options. So in part 2 we are going to look at it closely. I just want us to cover each of the tabs quickly. So you see here in OpenFast, even in the user documentation and the other literature document that was generated by Junkman et al., you will see that they provided tabulated information on lift coefficient, drag coefficient, and moment coefficient and other information for the different airfoils for their own wind turbine blade, that 5 megawatt wind turbine blade. But you see here, there are multiple lines here, which are the different airfoils that have been used for this 22 megawatt wind turbine system from IEA, the wind turbine blade from IEA. So you see that they have plotted all of this information. So it was generated, which is not tabulated, because if you are tabulating it, you are talking of multiple pages. But here we just have everything has been put as a graph, some of them interfering with each other and overlapping each other. So that's basically the aerodynamic data. So here you also have the airfoil information. You see it's also tabulated, which you also see in a notepad program when you are working with OpenFast. So it's possible if you have scrolled down, if you click on edit, you can actually edit the information here. But if you say you want something else, you can actually create a new one if you like. So that's basically, so it's actually here you can edit some of the information. If you want to change distances, maybe chord width, twist and the likes, you can actually make those changes here. So you now have BEM. So BEM, you have to actually generate it. So that's the blade element momentum. So on this panel on the right, that's where you come, you define some things. Once you define, after you define, then you can then start simulation. So it will now generate information. So you can select one of the options, whether it's tip loss correction or you are using DTO. There are different corrections you can actually use, but it's once you have clicked on define simulation that you can make some changes to how the correction of the BEM is done. So also here as well, you can then what you do here, it says turbine definition. You can define the turbine information. So there are different, once you click on new, there are different parameters you can actually change to suit your own desire. Whatever you want to do, you can actually make some selections here and some changes. So once you are done with those steps, you can then go to simulation. So here again, you define some things, like when you click new, you define some things before you then go ahead and you click on create. So that's where once you create that information, you now see it is going to give you a 3D animation of the movement of the wind turbine system. So here again, you can then describe a wind field. So it's possible to combine the wind turbine system, this wind field, as well as the movement of, that's the last tab, which is the wave generator, the movement of the waves of the ocean. So you can combine all of them, the wind turbine simulation, the wind field, as well as the wave movement. So all of them can be simulated as a combination. So this is basically QBlade Community Edition. It can be validated with OpenFast 5 megawatts wind turbine model. So you can cross-check how QBlade performs. So in subsequent video, we are going to look at how to actually run a model from beginning to end and see the animation. Then after that video, we are going to look at how we can generate our own model from the beginning, just as it has been done by QBlade themselves. I want to thank you for watching this video. I also appreciate all those who have taken the time to watch my other videos on OpenFast from part 1 all the way to 7. I see a lot of people have been following these videos and I really appreciate all of you. Thank you once again. This is Catchment of Resources, what we create for better living.